Whoa! What?
Seconds on channel. Power clear.
Okay, I know that the standby video was kind of glitchy. I don't know how bad this is. I'm on a super old laptop and trying to get it to work. I've been playing around with the streaming software for a super long time, and this is honestly the best it's going to get for how old this computer is. So I do apologize for if this is annoying. It's really not terrible once I start sharing my screen and CADing. It seems like it just has a lot of trouble playing the intro standby video without glitching like crazy. So somebody please put in the chat right now if you can hear me and see me okay. I know I'm at like 2 pixels, but am I glitching? Because as long as I'm not glitching, I don't care. Oh my. Who is this? Who is Neesney1? Oh, hello, Aaron. I'm not sure who this other guy is, but okay. We're gonna ignore that. So let's get down to business. I have a couple big announcements. Within the next couple of months, I'll be pushing out my merch store. I've designed a bunch of products, and you guys can purchase these products from my YouTube channel to support a good cause. I'm not getting rich off of it, but it does. Every little bit does help because these projects do cost me, at least me, a fortune. So, yeah, that'd be very appreciated. But anyway, today we're going to work on the final assembly CAD model for Aurora. And so Aurora is my TVC rocket that I've designed, and most of it's been 3D printed, like this nose cone and the TVC mount here and the avionics bay. This has all been printed, and basically I just got to put all the little things together and get it tested out. I've got some very basic code on it right now. I'm working with somebody to fine-tune it because it works, but it's a little jittery, so we're going to work on that. But anyway, the purpose of today's live stream is this rocket that you see right here. Before I actually launch the rocket, I need to do a test to make sure that the motor in the rocket itself can handle the thrust of the engine without dying, and B, to make sure that it actually functions to correct itself, because basically how this works is there's no fins to stabilize it, so this motor will actually move around the bottom here of the rocket to try to keep the rocket up straight. And so if it gets seriously out of proportion and wants to go into the ground, you're able to see this by holding the rocket down, like in another gimbal, watching it move around to like see how it performs in this test. So basically, a better way to say this is, before I go to launch this thing and watch it fail and crash into the ground, I can do a hold down test, hold the rocket, and watch how it performs within the hold down test, and then I can say, okay, it's probably ready for a first prototype launch, or okay, the programming needs a lot of work. Because, once the rocket's built, you've got your proportions right, and, thrust and all that's been calculated. It's really just a huge battle with code. And right now I've got the most basic setup I can possibly imagine putting on this thing. And it's really, you've got to keep it simple, because this thing gets really complicated really fast. It's already really complicated. This thing took me a long time to CAD. But anyway, I've got an Arduino with a couple servos and a gyro, and I forget what else I have on there. But yeah, basically I'm trying to keep it as simple as I can, because PID control is already a really big pain. And, I know very basic coding, but I'm not an expert. So anyway, let's get down to business, and I'll stop being a nerd and blabbing. And let's start assembling the model. I've already done all the CADing for it, because I figured that if I was trying to do a CAD live stream that everybody would just get super bored and leave. So what I'm going to do right now is just import parts, and we're going to start assembling this thing. So let's see. I think I might have to... Oh, this isn't the assembly, that's why. Hold on. Insert. We're going to insert this guy. Insert other documents. Now we're going to go back to the Aurora static fire gimbal mount. We're going to go inside of, let's see, I think it's either the outer gimbal. Can't recall. Yeah, it's not that. It should be within here. Actually, hold on. Yeah, I don't think I versioned it yet. I'm just going to import the whole assembly is probably what's going to end up happening, because this is outdated. So let's see. Yep, let's just go back in and reversion everything, make sure it's the correct version, because I think it's outdated for some reason. So, if we go into here, okay, who is Nisney1? Okay, I'm for, wait. Oh, is this August? Who is this? Friends with Andy. Oh, is this Connor? I'm guessing either Connor Fowler or August is this guy here. Tell me who you are. What's your name? Who is spamming my... Well, who is it? Thou must tell me. Alright, we're just gonna... Neither? What? Who else can this be? I don't know. Andrew has too many friends. I'm gonna be honest, I don't know. Who is this? Tell me. You're a troll? Yeah, I can tell you're spamming my chat. Okay, I'm gonna focus now. Create version, Aurora, static fire gimbal v3, create. Now I need to get this guy versioned. Actually, if that was the whole assembly, it should have worked. So actually, I don't know if I need to version all those other ones, but we'll see. So if I go into this and... Okay. Oh, wait. Oh, I'm so stupid. This is, This is Nick Hunsaker, isn't it? You troll. If this isn't Nick Hunsaker in my chat right now, I'm gonna lose it, because I don't know who else it is. Let's see. Where is the file owned by me? Aurora extract fire gimbal. Oh my goodness gracious, that is. Why is the bearing the only freaking thing? It's loading right now. Bro, it took me so long to figure that out. I'm very sorry, to be honest. Okay, this looks way too small to actually be the right size. But we'll go with it. Alright, Part Studios. Aurora full CAD. I don't understand why this isn't letting me import the correct part. So, no, don't want two of those. Yeah, let's just undo that, and then I guess I'll just individually import these. I'm sorry, this was supposed to be a very quick put together thing, because I don't want to bore everybody and have everybody leave. So, let's just see. Can we click move to document? Nope. Import, maybe. Export, no. Let's just version this. What did I say this one was? Wood mount with bearing V1. Create. I didn't CAD this guy yet, I don't think, but it might be correct. Let's see. Rename. No, not rename. Goob. Wood mount with wood cross beam V1. I should have done all this before. I'm sorry. I wanted to make this as unboring as possible. But basically, I am, as I already expressed, I am just putting these parts together for a CAD model, and then I'm going to buy the parts to build this. I've already ordered the bearings and stuff, and I'll probably have this done by mid-spring maybe. Wood mount V1. Bearings good. Plate for gimbal. What else? Nope, nope, nope. Okay. Theoretically, this should work. So, as a famous person once said, Aaron Cyrus, how are you holding up down there? Let's see. Alright, let's go back into this. I promise this is going to get a lot more satisfying very fast. Hold on, just let me get all the parts inserted. Don't make this inappropriate, people. Let's see. Where assemblies? No assemblies available. That's a bunch of crap. Where are you? You were here 2 seconds ago. Owned by me. Aurora status fire. There we go. Yay! Yay! This thing freaking annoys the crap out of me. Okay. No. Stop it. I'm mad. Okay, no. Yeah, let's insert this one. Alright. Boom. These are the parts for the mount. These are just going to be standard 2x4s that I'm going to put together for the actual stand. And then, wait a minute. What happened to the... I'm still missing the one that has a hole in it, so... Wood mount with bearing. These are... Oh, wait. No, I'm not. Yeah, it's right here. I'm sorry. I'm stupid. Alright. Let's put that there. That's good for now. So what we're going to do is this green thing is supposed to simulate grass. Don't ask why. Especially just don't ask. Okay, how do I rotate this? Like this. CAD is probably the most annoying but necessary evil pretty much ever. Stop it! Okay. undo, undo, undo. We're going to re-rotate this to 45 degrees. There's an interesting fact that I didn't know. Did you know that 2x4 wood isn't actually 2x4 inches? It's actually like 1.5 by 3.5. I never knew that. Alright. Left. View. Okay, obviously this isn't exactly 45 degrees because I'm a freaking goob. So we're just gonna deal. I'm actually realizing that this angle is super sharp. Probably more sharp than it needs to be, but that's fine. It'll be extra sturdy. I forget honestly how I designed this to go together, so we're gonna figure out as I go along. I was CADing this during school, so I wasn't really paying attention, if you know what I mean. And wasn't really paying attention to school or the CAD model, which is probably like the worst possible thing ever. 45 degrees. Aaron, am I more sophisticated than NASA? I bet I am, you sly dog. Oh! Would you look at that? It isn't aligned. Isn't that something? Bad. What? This is just getting worse and worse. Alright, I promise this will look more complicated in a second once I actually finish it. And actually, I'm just going to copy this, and then therefore I won't have to redo that entire thing. I love Control-C, Control-V. Goodbye. Alright, so now I'm just going to readjust this guy. We're going to look at this from the top. Just want to make sure everything's aligned the way it should be. Why are you doing this to me? There we go. Alright. And then just double checking everything else. Looking good. Top. I swear this gets more interesting. Let me just get the boring 2x4s assembled, okay? Just bear with me for a second here, people. Just bear with me. I swear it gets better. I swear. Alright. And then we're gonna... Let's see. What's next to import? Should I do... We're going to import the gimbal. Alright, so we're going to import this gimbal, which I spent a solid 3 days CADing. Holy crap, this thing is a lot smaller than I thought it was. There's no way these are actually the correct size. That's all I'm going to say. Just kidding. They should be exactly the right size because I spent time designing them. Wink, 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 wink. I'm super good at designing stuff. Nobody can tell me otherwise. Or I'll ban you from my chat into the shadow realm. No, 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 no. Alright, so this is the gimbal that'll hold the rocket. I gotta rotate it now. There we go. Once I import the actual rocket and then, you know, extend this grass out so it looks better, this will look better and more cool, and you won't leave me. Thank you, people watching still. I appreciate it. Aaron, I have a question for you. Like, what what quality are you viewing this in right now? Is it like 720p or like how low is the quality? Let's see. Because like so it's 720p? Okay. Yeah, I basically when I was doing the live stream standby, every time I do that, it's always glitchy, and I think it has something to do with my crappy computer. But yeah, let's go over here. 720p. Okay. I'm curious, what was it when I was doing the live stream standby? Because I think it was at like 144. Because the computer has like a seizure every time I try to do that live stream standby, and it upsets me a lot because I like the live stream standby and I spent a little bit of time editing that video, but it's like, oh my gosh, this looks absolutely way off. What the heck happened? But anyway, it's like it won't load, and I've been trained. I don't know if you are familiar with the software. But it's OBS Studio streaming software is what I use. I don't know exactly what this computer is, like what year it is. I just know it's an old HP laptop from, I think, circa 2009, 2011 is when we got it. And it's all I got. So I gotta treat it well, I guess. Okay, why isn't this aligning? I'm genuinely confused. Left, there we go. So let's go reduced rendering performance check. I don't give a crap. All right. Let's see, and then let's put this guy in here. Is this aligned? That doesn't look aligned to me. All right. Oh my God, what happened? Yeah, that's not supposed to be like that. All right. Once I get this gimbal like in here, it will like most definitely go a lot quicker. All I have to do is put in bearings as well, which, you know what, actually I think I might do that right now. We'll see. But yeah, I had to. What computer is it? The standby was actually pretty good. It only cut a few times. Might be just on your end. UHP old Dell anytime. Yeah, so in my OBS studio, I had the encoder set to, I forget, was it like, I think it was like 2,500 kilobits per second or something. Let me see. It's a really low bit rate. Yeah, 60 frames per second, 720p, 48 kilohertz audio. Output was, yeah, 2,500 kilobits per second. I don't even think that's the right term. I could be wrong. For the encoder, which is considered pretty low. Usually standard's like 6,000, but every time I tried to put it at 6,000, it had like a seizure and said it was too high because the computer couldn't handle it. It said encoder overload, so I just didn't do that. And then I have the encoder set to times 264, which from what I've done is okay, or from what I've read is okay. But most people like using this NVEC type encoder thing, but my computer doesn't even have, it's so old it doesn't even have the capability to do that. But anyway, enough nerd talk. Let's go back to CADing. Stinky, stinky CAD. Okay, we're going to deselect this, and we're going to move this around so that it actually looks like it's, you know, aligned with the thing it's supposed to be aligned with. So let's see. There we go. Now it's aligned. Anyway, back to the story I was telling. I ordered 22 millimeter bearings with a 10 millimeter inner diameter, 22 millimeter outer diameter, and then a 6 millimeter thickness. And those are going to be used in this gimbal here that you see that I am desperately trying to align with this stupid thing. And I had to order a special hole saw just so I could cut this. But basically, once those bearings come, I'll probably get these assembled and put together. I'm not sure why this isn't letting me slide this, but let's see. Let's go front plane, and we'll slide the entire assembly out, God forbid, and let's see how it looks. It needs to go out more. Honestly, I might extend these shafts for the bearings to be a little bit longer so that this thing has more play in it, because right now it seems really really close to this thing. I mean, I think the problem might be with the mounting clamps right here that I've got. Which, hold on a second, I might have been the entire time assembling this incorrectly. Oh no! Yep, this is the wrong version. Yep. Goodbye, goodbye. I am an idiot. Oh my gosh, I hate my life. Okay, once I get this stupid gimbal in here, where is it? Here it is. I'm a dummy. What a goob I am. This is the correct version. See how everything's the same color and everything looks much better CAD'd, and the inner gimbal shaft is actually aligned with the hole, which the other version wasn't, because it wasn't a finished version. I'm a goob. Yeah, this thing was actually a big pain to CAD because Onshape was just not having it, and it was glitching, which happens sometimes. And I just hate it when that happens. So yeah, let's get this stupid thing up here. Let's look at it from the top plane. Let's rotate it. Okay, I swear if I'll get this done faster. Please be patient with me. I am an old man with an old computer, and I have no idea what I'm doing. Alright, let's go that way. Let's go this way. Let's look at the side plane. Look how much faster this is going, kind of. Let's put you back here. And then let's slide you down here. And then slide this through. Right. Realign you. That's not aligned. Yeah. Let's go like that. Let's see how much better this is. And then, what is it doing, man? Why does it keep going like this? Oh, I see, because it's at an angle and I rotate it. So, alright, so let's go like right there and see. Oh, that might be it. No, it's super close. Let's go. Let's go like right. This isn't taking the wood up with it. What the heck is going on? Why is it taking the wood too? Oh, because it's not selecting this. I see. Alright, let's see how that looks. And then, yep, that should be good. Let's go. It doesn't need to be perfect. It'll be fine. Alright, this guy, and then this needs to get slid back to where it's supposed to actually be. Wait a minute. Did that? Oh, that's. I don't know what the heck that's from. Let's just delete it because I already have the pegs correctly lined. Alright, so here comes the fun part. I swear. Alright. It's actually an entertaining part. We're going to move this together. Okay. You ever have that moment where you're like, I'm stupid, and you realize that, theoretically, just because this gimbal has, full range of motion on the X and Y axis for the actual gimbal itself, but then you realize it's only like, what, 10 inches wide, and that the rocket is long and tall, and it needs to, the bottom of the rocket's going to bang on the wood, then you kind of realize that you're an idiot. So what we're going to do is we're going to go back into the full CAD model, and we are going to edit this shaft to be, and the other one to be a lot longer so that this thing has more room to, actually freaking move. And this is going to be interesting because I'm not really sure how well this 3D print is going to hold like 20, 30 pounds of total weight. So, yeah, we'll see. I'm on the robotics team, and we've used 3D printed parts on the robot, and they work for like 2 hours and break. So, static fire is only 20 seconds. So, therefore, my theory should work. Aaron knows what I'm talking about. Yeah, Sly Dog. Alright, so I have to edit this in context. So we're going to go all the way back to this guy. That little goob. Alright. So, back to what we were doing. We're going to edit. Sorry, I'm getting like sidetracked. Someone texted me. Okay, so we're going to edit this guy. Edit in context. Context 1. And we're going to see if, God forbid, this... Oh my god, I forgot how many planes I made for that CAD model. We're going to edit this extrusion and see how well this guy is going to work. So we're just going to go to 10.2, which should be way too long. Let's see. Let's just go... What did I have? 6.2 earlier. Let's go 8.2. And then, how much should I just increase that by? It was 6.2, so this would be increased by that much as well. Let's go up to 10 just to be safe. I don't really think this is going to work well. I think this print's going to want to snap. I've got to figure out some sort of a design to hold this thing down. I'm not quite sure what will work well. But we'll do this for now, and we'll see. So, let's go back to this guy and see if it updated. Yep, it did. So we're going to version this guy. Aurora, static, fire, gimbal, mount, version 4 is what I think. Create, return, go back into assembly. No! Hello, Emma, I'm on a live stream. Emma. Okay. So, what happened? Emma. Let's just pray that when I up... No. Don't you dare.
My God.
Oh. This is so stupid. Okay, I'm going back to... I'm going to go back to this guy. Let's see. No! Jesus, this is annoying. I clicked on it. Insert document. What is happening right now, dude? Alright, Onshape's having a brain fart right now, so let's delete these guys. Okay, this is definitely not how this was planned to go. It's freaking glitching. Of course, when the live stream works, the CAD software starts acting up like a piece of garbage, so I'm clicking delete! Delete! Load. Oh my god, there we go, finally. Alright, so, Emma, stop! Yeah, when you have a sister, live streams are not a thing. You know, they just aren't gonna happen. I'm trying to think. I feel bad for telling friends and family to join my live stream and then boring the crap out of them with my stupidity. Alright. Let's see. Click, click, clicky, click, click, worky, work. Work. Top. Let's see. Alright, once I get this gimbal taken care of and assembled, this actually will go by super fast. I just have to get this stinking thing aligned. Which, I'm not going to jinx it, but let's see. Alright, that looks good. Alright, so from here, it should be a breeze, and some of the satisfying stuff should start happening. So, we're going to put, you know, I'm not even going to worry about these. These are support beams right now. I'll get them taken care of in a minute, but they're supposed to go across these guys as a cross brace. So let's insert the bearings. And this guy. I don't know where my bearing went. Here it is. Moving around. Okay, stop being in my way. Alright, so we're going to click right plane. We're going to click rotate 90 degrees. We're going to go boom. Alright, so these bearings essentially go in here. Honestly, I might consider redesigning, because this guy should be way more beefier, in my opinion, because it's like practically way too tiny. Why are you not letting me copy? Control C, Control V. That's how it works. Okay, now we're gonna move up here. Where this went here. Alright, so I'm thinking this guy needs a design tweaking here to see how well we can get this to work. Because this, honestly, right now is a really thin axle. So what I might do is shift over to a larger size bearing. We'll see. Alright, now I've just duplicated a set of bearings. We're going to move them all the way over here. I think the bearings for the gimbal itself should be fine, but I think that these bearings on the outside need to be a lot thicker because they are really, really tiny. So like these bearings, I'll probably at some point change the design and make those bigger. But for now, I'm just going to get this thing together and see how it goes. Which I need to cancel my order then. Let's see. Control V. Let's put this fella right there, and let's do another one. Control V. I don't know if it copied. Hold on. Well, that's the function key. That's why I didn't copy. All right. I don't know what degree this has to be rotated to. Oh, it is aligned. Let's go. 90 degrees. And I should have just done the other one of the same thing, because I'm a moron. Once I put the rocket in here, it'll look cool. Let's see. And front. CAD is such a necessary evil. Oh my gosh. Alright, so we'll put this bearing in here. So I think I'm going to keep this bearing size for this guy. And then for... Let's see, how well does this align? Let's see, checking. I know this shaft doesn't align perfectly. That's just because it's too lazy to perfectly align it. I know it does align fine when it's done. Where in the world did that bearing go? Whoa! That thing just vaporized. Where is it? Oh, it's hiding right there. I didn't see it. Alright. So, I've got bearings in here now. So this is supposed to rotate freely that way. This guy, for a 3D print, this pretty much has like a 100% chance of breaking off, which is bad. But we're going to ignore that for now. I'm going to cancel my Amazon order probably, and we're going to just insert the rocket just to say I got this done. And then question my life choices. The end. Owned by me, this guy, create a version, 104 version changes since the last version. Part studios need to be inserted. Assembly 1, just shut up and let me insert the rocket, please. A 104 changes since the last version. I find that extremely difficult to believe. And then let's just put the rocket like right there. Of course, the entire stupid thing. What is that? No. Alright, oh thank god it does let me select it and I don't have to do it individually by parts, which is what I thought I had to do earlier. Alright, so we stick this guy right here. I think based on how it's been catted now, the center of gravity is probably going to be around like right here. I haven't fully tested that yet. Here's what we'll do. And this is good though, I'm noticing this now because this is going to be helpful. So when this goes to gimbal around, this is how it's going to work. So here's the assembly. It's not fully, there's some way to animate these gimbal work, but it's supposed to, this gimbal is supposed to allow it to fire and test with inside these parameters. But let's see, if I rotate it like this and move it like in the center where it would be theoretically. Honestly, it isn't really. Yeah, I probably could shorten these shafts a little bit, but I still want to thicken them because 10 millimeters is only a centimeter, and I feel like that is way too thin for something that needs to be able to be this durable. I think it's fine for these guys, which they need to remain that way, but for these outer ones, I'm probably going to switch it to a much higher millimeter rating. So yeah, there's that guy. We will edit the context of this one. Sketch. And then, oh, I can't remember which dimension was which. I'm just going to click edit and context. Wait, what's wrong with this one? Update? Sure, if that's what you need, I don't know. Watch it like disappears or something stupid. Goodbye. What the actual heck is going on? Why do I have two? What the hell is going on? Okay, goodbye. I don't know what all this shit is. Oh my gosh, excuse my language. This is just frustrating. Go away! Go up. No, I'm frustrated. Okay, I'm clicking delete and it's literally not deleting. There's a reason why there's a delete button. Why would I want to delete that too? Oh my god. What is happening right now? Yeah, this is weird. It's somehow confused about. Yeah, this isn't. Maybe this got screwed up. Let's see. Why? Yep, it's this guy. It's this stupid thing. I don't know why, but it is this stupid thing. See, it's funny because I'm trying to deselect it, and it's like not freaking deselecting it, so. What part is this? My god, I'm gonna lose my temper right now. It is quite frustrating. I don't even know why this thing just decided to freaking magically unalign itself and do this to me. But for whatever reason it did, and now I've got to freaking re-CAD it, so that's great. So we're going to select, and then scroll out, move it all up. I'm not sure why it thinks this is. What's so weird about this is I never went into this file and changed this to be unaligned like that. So I have zero idea why it just decided to randomly freaking do that to me. I don't know. It'd also be interesting to see if it, undid the slots I cut for the servos, because that would be a big pain. Okay, so it didn't do that. Good. Is everything else correct and okay now? Yes, it does look fine. Okay, I'm going to create a new version. We'll call it region 1.3. I am terribly sorry, everybody, that this had an error. This was supposed to be a lot faster than it was. So, alright, now let's just delete this stupid thing or update it. Watch it like inserts 2 rockets. That would be pretty funny, honestly. Oh my Lord, have mercy. We're gonna delete this whole thing. Goodbye. Go away. I'm sick of you. Ruining my fun. There we go. Yay. Now select assembly again. Realign it since it had a seizure for some reason. I don't know what happened right there. This has never happened to me in Onshape before. Quote of the day, 2023, Dominic Bleacher. Alright. Let's align this, make sure everything fits okay. These are clamp down 832 bolt things that will hold this rocket on. So let's go to the front plane. Raise it up to about where I think it would be. Now let's edit the context of the grass plane. Edit context. There we go. So now I can go into the sketch. I can tell it that this is way too large, and we can shorten it down to, let's go with like 24 inches. Yep, that's better. And then for the length, let's make it like, I don't know, like 60 inches maybe. Oh yeah, so I'm gonna have to move it. That should be enough eyeballing it. Alright, let's go back into the assembly. Look at it from the left plane, and we'll slide it this way. Watch, it's not enough. Yeah, it's not enough, darn it. Yeah, so we're gonna make it 70 inches. Edit in context. I also noticed that this isn't cut fine, which is a big pain as well. Honestly, I don't really care about it because it's 2x4s in wood, and some people would have a panic attack and want to get it perfectly catted. I don't really care because it's wood and I'm going to be cutting it, and it doesn't need to be precise. It's just a crappy mount. The rocket stuff, that needs to be dead on precision, like exact measurements for everything to fit. The gimbal mount, I don't really care about as much. So sue me if you want, but I think it's fine. Let's see. Oh my god. Let's do edit in context one more time and go to 75. I know this is stupid. This is not even a part of the rocket, but whatever. Y'all, if you think this is boring, actually designing it is way more boring because I've already spent hours designing this. So, alright, you reach a point where you say good enough and I'm done. So that looks like that is way too long. Oh, well, I don't care. all the things in the stuff, and this gets moved, and this guy, the top plane, go like this, side plane, rotation, we'll go like, let's go back down where it was. I was going to make it like go across, but I don't really care. Alright, let's see. Do the same thing for the other one, and then we'll just make it longer by, I don't know, however long that is. We'll measure it with the measuring tool that provides you on shape. So, yeah, we definitely learned a lot today, including that, you know, I need to learn how to use CAD better. Just kidding. I mean, I'm not bad. I taught myself a lot of this, and I'm still learning. This is relatively new to me, so. Alright. Move it out this way. Okay, cool. And we'll edit the context. Alright, extrude 10.5. That's pretty decent size. Let's see what the back side of it is. Make it 15. Good enough. Done. 15. Straight up. Good enough. Good enough. Alright. Go back to my CAD model. Alright, y'all. What in the world? Edit in context. What are you talking about? Create version and update in assembly. There we go. And let's just delete this. Control, blah, 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 da, 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 da. Alright, move you around. Alright, this is just supposed to be a support beam, so I don't really care about it. But let's see. Which one is the right axis to move? I think, yeah, I'll just wing it. Okay, so, yeah. So guys, here we go. This is pretty much it. I don't really know. I've got a lot to think about. This is the good enough model for now. Obviously, this guy needs shortened, and then the angle on these 2x4s might need to be adjusted. That really doesn't matter. It honestly might be better if these are slanted like that. It'll grip the grass better. But anyway, we've got this right here is the rocket and the gimbal. So it's a gimbal within a gimbal to test its gimbaling abilities. So yeah, the rocket motor gimbals, and then this guy right here gimbals so that you can test the motor. I don't know. I've got to do some thinking about this because this gray stuff right here is going to be 3D printed. this brown stuff is wood, and then these are bearings that I'm ordering. So I definitely foresee this snapping off like right here. I mean, even if I print it at a really high infill, I'm not really sure it might work. I don't know. The thrust on this thing is kind of high. So I'm probably going to thicken this up, just these outer bearings for that axis, and then I think the inner ones are fine. That'll be good enough, but I think the outer ones definitely need to be thickened. So I think I'll keep my order for the bearings that are in this gimbal, and instead of using those same bearings for here, I'll use thicker bearings and thicken this up. I don't know. I'm going to talk to one of my friends who's got more experience with 3D printing and ask him what he thinks, if this will break. I have a high chance of thinking it probably will, just because it's, I forget how thick it was, like 10 centimeters, or 10 millimeters, sorry. So yeah, it's really not, it's only a millimeter, or what am I saying, only a centimeter wide, which really is not that much, so I'm definitely going to thicken those up. Shake a Hill, who commented in the chat, thank you for supportive comment. I don't know, did YouTube feed this video to you, or did you get to this video through like, because I don't know, how did you get to this video? I'm curious if you're still on the stream. I don't know, he might have left. Well, whoever Shake a Hill is, thank you for the comment. I appreciate it. This can be frustrating sometimes. It's definitely not easy. And Aaron, that's funny. Yeah, I plan on doing a static fire hold down test with some version of this gimbal mount, hopefully by March. Oh, hello! Hello! Oh my gosh, how did you get to this? Oh, you subscribed. Okay, that's awesome. I appreciate it. Yeah, so, yeah, thank you guys for showing up to this. But yeah, so this rocket in the middle here took the longest to CAD. This guy took me a couple of months, and this was like the first CAD model I did where I actually put a lot of hard work into it, and I'm actually pretty happy with how it came out. And like I said, like the Aurora, the electronics bay is already assembled. This nose cone is already assembled, and so is the rocket motor mount. I just have to like drill the holes and screw everything together. But I plan on probably doing the static fire in, we'll say like April. It's a good thing because I have to get one of my buddies to help me with the code. It's there and it works, but it needs a lot of fine tuning. Thank you. Yeah, thank you guys for the support. I really appreciate it. I honestly, that's part of the reason why I keep doing this, because I get a lot of support from family and friends and other people that care about this, and it's helpful. So, Dad, like, I can't see it. But anyway, yeah. So basically, this guy right here is all CADed, as I already said 100 million times. We're gonna go back into my channel here, and I have a explanation to this thing right here, which is related to the rocket. So right here is an E12-4 rocket engine. The whole point of this was I was trying to see like if I could design my own rocket igniters that were more reliable, because the ones that come with standard SS engines are really unreliable. They misfire all the time, and they're just really not safe. Aaron Cyrus, who's in the stream right now, we've done a rocket launch together, and he knows from like the first launch we've done that they are terrible. They misfire all the time. When they do work, they work good, but they are usually delayed from like when you hit the controller, like the launch button. It takes like several seconds for it to actually ignite the motor. And so I wanted to like make my own igniter that was more instantaneous and more reliable, because this project is more complicated, and I'm trying to keep everything as safe as I possibly can. Because with TVC rockets, and I'll show you in a second. But anyway, I ended up just using the standard one just to get this good video of a close-up engine fire. This is probably one of my more favorite clips that I've shot. But yeah, I was testing that day to try different igniter types. I'm getting closer, but it's not quite there yet. We're going to try to do that. But let me show a video of what a TVC rocket failure looks like, because this is exactly what I'm trying to avoid. No, not that. That's a real rocket. This is what it should not look like. That one's actually not too bad. That guy is okay, never mind. Yeah, right there. That's what I don't want happening. So this is really complicated. I'm working most of this problems that this happened with this swirling around is because the code is got a delay or the computer gets overloaded, and it's just a big pain. So I'm working with somebody who's going to try to do the best he can to get this to work with an Arduino, which is a very basic flight computer. I have got a basis started for a custom computer that I'm designing, but that's a long way to go. So anyway, what we're going to do is probably call it a day. This guy needs to be widened. Like I said, I need to talk to a guy with 3D printer about how this is going to go. And then the design for the parachute throw, which I'm also working on for code, is the idea was that motor you just saw fire. How this motor works is essentially it has the propellant charge, and then after it's done firing, there's an ejection charge right here. So here's the thrust coming out this end of the motor, like that. And then after it finishes firing, there's a delay, and then it will shoot a gas charge through the other end of the motor, right here. Let's see if I got the... Yeah, so see the fire? That's the gas charge it shoots. And that is supposed to use pressure to push the nose cone off on a standard rocket, but you can't have a gas charge going up through electronics because you're going to blow your rocket up. So what I'm going to do is I'm going to plug the motor, which does work, and then to throw the parachute instead, there's a servo here, and there's, I don't know if you can see, but this is a door, and this will have a little spring in that cylinder there, and so when the servo moves, the spring's going to shoot this door off, and the parachute is going to come out through there. And so the lazy way I was going to try to code this myself was to say, okay, the motor's done burning at about 3 seconds. We'll say about 3.5-ish seconds. You need to turn the servo, and that'll be about apogee. The problem with that is you don't know if it's at apogee at that moment, and it's a really inaccurate way of doing things. So I'm going to actually try to utilize the accelerometer to say, okay, I'm starting to read negative acceleration values, which means I'm heading towards the ground. As soon as I start reading those values, I need to throw my parachute servo right now. But to do that is not very easy. So yeah, at some point I have another live stream video from a long time ago with the code. It's really basic, but we'll see how everything turns out. I'll keep you guys updated. I have a lot of pictures. that I'll probably be posting, and I have a video coming out sometime this month that's going to be about every single model rocket I've ever launched. And I have to admit, when I was editing the video, it really hit me that I have launched quite a few rockets in a short period of time. And it was really cool to watch. But anyway, y'all, thank you for tuning in. The project progress on this might be a little slower than usual because I'm during my robotics season right now and it's quite busy. But I am trying to keep progress going on this. So yeah, this looks really cool. So thank you guys for tuning in. I really appreciate it, Aaron and Uncle Jim and Shay. I really appreciate it for you guys tuning in as well, and for my neighbor and Andrew who were tuned in earlier. You guys are very supportive and awesome. This can be quite challenging sometimes, and to have other people there to support you means the world. So I hope you guys have a wonderful Saturday evening. I will keep updated posts in the community tab of my channel. And I have last announcement that I have is I'm going to probably also post a video saying that like I have a big project for, you know, if I hit 1,000 subscribers, whoever the 1,000 subscriber is, I will do a special project for them. That's also a plan. I don't know when that will happen. And then the other big project I have was hinted in my 100 subscriber special, and which was also played at the beginning of the live stream. But essentially, I plan on having this guy right here, this rocket, TVC rocket, launched by sometime in summer without the static fire mount, like an actual launch. And then I'm planning to go for my level 1 high power certification for high power motors. And I've started talking to some people about that because that is a whole other process. And it's very time extensive. But anyway, one last time, thank you all for tuning in. Have a wonderful evening. Be sure to turn those notifications on so you get updates when I post new content. And like I said, sometime around March, April-ish, I'll have a merch store up in case you guys are interested in that. So, have a wonderful evening and peace out.